So this is called exponential growth. Okay, so exponential growth is when a graph is increasing as time goes on. So if I look at our graphs over here on the graph board, it would be like the blue one, right? So it's getting bigger as time goes forward. Now in each of these parts of the equation, each part means something. The y is a lot like what your output will be. It is your output, but it's like how much money you'll have if this certain thing happens. The a is going to be your initial amount, so how much you start with. Now the 1 is always there. The 1 means you get your money back. That's what the 1 is for. So if you got 100% of your money, you gave me 20 and you wanted 100% of your money, I would give you 20 back. When we start talking about growth, that's where this 1 plus r comes into play. Meaning you're going to get more than 100%. That's where growth comes in, and you have to have an r to do that. Now the rate does have to be as a decimal. So if I have 3%, how do I change 3%, 3% to a decimal? I think most of you talk about dividing by 100. I talk about moving the decimal place. Either way, you'll get the same thing. 0.03 would be the amount you would need to use for the rate. And then t is always the time. Okay, so the time that you're going to do it. So if I'm going to go look at this problem, here's a function that deals with population. Okay, population is 40,000 in a town, and it is growing by this amount, right? But recognize that really that's 1 plus r. So keep that in mind. So when it asks me to find percentage, I want to take into consideration that I'm taking this thing right here, 1 plus r, and I'm using it to find this. So if a question asks me to find rate, I want to make sure that I'm using both of those things in yellow. So it's going to look something like this. I'm going to go 1.5 is equal to 1 plus r. And then you solve for r to find the rate. So I'm going to go subtract 1 from both sides. 0.05 is equal to r. Now that's as a decimal, so that would be 5% would be my increase. Now the question that some of you are asking in your head, and maybe not going to ask out loud, is, okay, can I just like steal the 5 from here? I wouldn't. I wouldn't just steal the 5, because when we start talking about exponential decay, you don't just steal the number. So if you got in the habit of just stealing the number, you would then try to steal the number and think it works all the time. It only works to steal the number in growth. It does not work in decay. So I'm going to continue to teach it like, hey, setting this yellow parts equal to each other and solving for r. Now the second part of this says find the population in 2017. How many years from 2010 to 2017? 7 years. So I'm going to go put a 7 into this equation down here. So it'll look something like this. Y equals 40,000 and then 1.05 to the power of 7. And you can go ahead and put that on your calculator. Go ahead and do that now. So when you put that in your calculator, you should have got 56,284. But keep in mind that these are people, right? So we want to make sure we have whole people, no partial people. Later in your homework, I think you do one with bacteria. Then you would do decimals, 4 places on decimals. Okay, 4 places on decimals. If we're dealing with money, you'll go 2 places appropriately. So just keep in mind that the context of the problem is important. Let's do another example. So here we're talking about people in viewing my website. I wish there was 500,000 people viewing my website, but there's not. But that's my initial amount of members. So that's going to be 500,000 or 500,000. Percentage of growth. Again, I'm going to take this amount in yellow and set it equal to 1 plus r. Because 1 plus r is the original formula, so 1 plus r is going to equal 1.15. Subtract 1 from both sides. R is equal to 0.15 or 15%. Now again, I know you want to just go grab that 15 from there because it's really easily visible, but it is not like that when we do decay in a little bit. So I would just get used to using this to try to find your rate. How many members will there be this year? So we're going to go ahead in 2010 until now, that would be 15 years. So we're going to go ahead and put a 15 in there. To the power of 15. Go ahead and put that on your calculators and see what you get.
How would you do that on your calculator?
Okay, so this is what you should get when you have your total number of people. If you're going to do it at 15% for 15 years, you'll get about 4 million people. Now let's talk about it when it talks about your money. right? This is that one day in high school math that you actually might apply to what you do in real life, right? Now I'll preach this every single day. What I do is important. You learning critical thinking and problem solving is important to your future, and none of you know if you'll never use math. You can't tell the future. I promise you don't know. It might prevent you from getting into college if you don't do good at math. It might prevent you from getting a job if you don't do good at math. So the math is important, but this actually does apply to your daily life. If you go put your money in the bank, they will give you money for your money. It's kind of sweet. If you put it in there for a set amount of time, called like a certified deposit, a CD, then they'll give you more money because they're like, hey, you're going to let me use your money for 5 years? Okay, we'll give you more money for that. Now, savings account is what most of us use, right? Because then our money can come in and out easily. It's not like locked in. When they do that, they give you a less interest rate, so a smaller rate. Most of us probably in here, if you have a savings account, are making like less than 1%. Not very much money, but it's free money. So you're going to be asked to write equations in your homework today. So besides me giving you the equation, now you have to write it. So let's go write this one. I know I'm earning, so I'm increasing, I'm growing. So y equals my initial amount is $500. Parenthesis 1 plus my rate. Well, my rate was 4%. 4% changed to a decimal by 0.04. And then to the power of t. Now, if you left it like this, I'd say, hey, thanks, you're really, really close. I'd give you like a 3.5, but we do want to clean it up a little bit. So cleaning it up will look something like this. Y equals 500, 1.04 to the power of t. Okay, so that's what your equation would look like. Now, if you put that money in there for 18 years, you'd find out how much money you'd have if you start with 500 and put it in for 18 years. Go ahead and put that on your calculator and see what you get. Okay, so exponential decay is like the red graph over on the graph board, right? You're actually losing money or losing value, and that happens all the time in real life too. Guess what? When you drive your car off the lot, loses value. Right now, homes are gaining value, but if we had a recession, homes would lose value, right? Things would be worth less money, right? So that's where exponential decay comes into play. When you take, you'll find in your homework, an ibuprofen, right? That has decay. It starts and gives you a lot of relief from your pain, and then eventually it goes away, right? Less and less every time. So decay is when something is less than 1, meaning your multiplier in here is less than 1. So let me talk about 2 examples I want to show you. If I write y equals 100, 1.13 to the power of t, and y equals 100.97. You want to be able to look at these 2 equations to decide which one is growth and which one is decay, and why. So this one that I wrote first, this is growth, because the stuff in the middle, the multiplier, is greater than 1. Okay, the common multiplier is greater than 1. It's 1.13. That has nothing to do with the rate, okay? But I can look at that stuff in the parentheses and say, hey, that's growth. This one is decay, because my common multiplier is less than 1. 0.97. So that one would be a decay function. And you want to be able to tell the difference by looking just at the equations and why they are that way. So if the multiplier is bigger than 1, it's going to be growth, like the blue graph. If the multiplier is less than 1, it'll be decay, like the red graph. Now let's practice. There is what I want right there. So here's my equation. Before we start, growth or decay? Decay, right? Because it's less than 1. That 0.95 tells us it's less than 1. So first question, the 5100 represents the initial population. The initial population for this specific town, 5,100 people. Common multiplier. Now the common multiplier is like yesterday. What am I multiplying by every time? In this case, I'm multiplying by 0.95 every time. That allows me to know it's decay, because that's what I'm multiplying by, and that multiplier is less than 1. That does not mean the rate. 0.95 is not the rate. Rate is that 1 minus r. So I have to take this stuff and set it equal to 1 minus r. Similarly, like I did with growth, so 1 minus r equals 0.95. I solve for r. Subtract 1. Negative r equals negative 0.05. Divide by negative 1. Rate equals 0.05 or 5%. Now those of you that just kind of wanted to steal the number in yellow, clearly that 5 is not easily seen. It's not easily visible. You had to do some math to get there. Now will some of you do mental math? Absolutely you will. But don't just steal the number in yellow, because it's not. The rate is not just the number in yellow. The rate is what we do 1 plus or 1 minus to get that. Now, if I want to find out what the population is in 7 years, this is exactly what our school district is doing right now, because we're having a declining population. So they're running calculations to determine how many teachers we need, how many kids can we run, where are we at. Like they're literally using this decay formula. It's happening right now in our school district. Okay? So I'm going to go put 7. What's the population of this town going to be in 7 years? So P will equal 5,100.95 to the power of 7. Order of operations says you do the exponent first and then times by the 5,100, or you can put it all in your calculator at one time. Go ahead and do that. Okay, so you should have got 3,562 people if you put that on your calculator. Last one, last real life example. Kelly Blue Book. Your car is going to lose value. So you need to know, am I using growth equation, 1 plus R, or am I using decay equation, 1 minus R? Well, guess what? If you're losing 10%, this is going to be a 1 minus situation, 1 minus our rate. So this is exactly how they determine how much your car will be worth when you go to resell it. So if you buy it new, or not even new, if you buy it, and then you go to sell it, they're going to take this and use this formula to determine what your car is going to be worth. So this is how we would write the equation, but I'd also want to clean it up, right? So simplify where I can. So y equals 23,500.90 to the power of x. It is decay because my car is losing value. And if my car is 8 years old, how much can I charge people for my car? What can I list it for on Facebook Marketplace? So y equals, go put this in here with an 8 in for the x.
Can't you list it whatever you want?
You can, but it won't have you what it's worth. So then people will be like, oh, should I charge, like if I charge 20,000, they'd be like, I'm not going to pay that. Because it's really only worth whatever we're about to find out. $10,000. So that would be what what I should list my car for. That's what Kelly Blue Book will say my car is worth. So go ahead and grab your worksheet from your sub, and if you have any questions, you can see me and Win, because I will be there today. Thanks.